Hello everyone, and today I am going to solve this JEE Advanced 2025. This question was asked in paper 2 and this was considered to be one of the toughest problems because of long algebraic manipulation, and that too in exam point of view. The way the solution has been presented in the internet is too devastating, which can lead to a lot of silly mistakes. But here I'm gonna pose a very elegant solution for this problem, which is actually an exam friendly approach. Okay. However, I will not be solving the entire problem. The entire task is to solve locus S, and once locus S is found, the rest is not that difficult. It's simple. Okay. Now I'm assuming that you must have gone through this question and you must have solved it before. If not, then please pause this video and try it by yourself once. Okay. Use whatever methods that you knew before. If your method luckily matches with this method that I'm going to show, then it's great. Else, no problem. I'm going to anyway solve this using the elegant solution. Okay. So I'll just revise what this question says. The question says that yes, denote the locus of midpoints of those chords of parabola y square x equal to x such that area bounded is 4 by 3. Okay. So they are saying that there is a locus S such that the area bounded between the chord and parabola is y square x such that S is actually traced by the midpoint of that chord. Okay, so let me draw a diagram quickly. So here is the diagram that I have drawn for y square equal to x. Okay, and this is the chord. Okay, so let us assume that this is A. Okay, I hope you can see. This is A and this is B. Okay, now here I'm going to use a very simple concept of tension and max. Okay, and that simple concept is what I'm going to quickly revise it for you to see if you can remember it or not. Okay, so the simple concept is that if you have a line segment, let's say its endpoints are A and B. Okay, and let's say A is xa comma ya and B is xb comma yb. Okay, and you have a coordinate axis. Let's say this is y axis and this is x axis. Okay, let's say that there's a point P whose coordinate is xp comma yp. Okay, and let's say P divides AB internally in the ratio m:10. Okay, and this is valid even for external division also, but for generality I'm going to show the internal division. Okay, so if I drop three perpendiculars from A, B and B, okay, if I drop three perpendiculars, then can I say that this will be xa, right? Because this is x-axis, so y will be 0 everywhere. Okay, this will be xa, this will be xp and this will be xb, right? Now using section formula we know that xp is actually m xb plus n xa by m plus n, and similarly it works on y-axis also, right? That m yb plus n ya by m plus n. Okay, if this x is appearing here, then the same xp will appear here, right? So m xb plus n xa by m plus n, and obviously it's comma 0. Okay, if this is true, right, and this is also true, then can I say that this will also be n-10, right? This is a simple thing. I don't think it's really difficult. Okay, and similarly you can do for y-axis also. Here you will find for y-axis it is something like this, right? If these are perpendicular, and this will be in the ratio m:10. Okay, so I hope this much simple thing you must have understood. Okay, using this simple concept I'm going to solve that problem. How? Let us see. Now I'm taking P as h comma k. Okay, and since P is given as the midpoint, so what I'm going to do is that I'm going to apply symmetry over here, right? Because it's the midpoint. How? If P is h comma k, then this will be h, right? Right or not? If I drop a perpendicular from A, this will be h plus beta, right? If I assume this to be beta, I hope you can see, right? If this is beta and this is h plus beta, can I say that this will be h minus beta? This one, okay? So I hope this much understood. And since this is h plus beta, so my A coordinate will be h plus beta comma, and if I apply same logic over the y-axis also, then this will be k plus alpha and k minus alpha. Okay, why k plus alpha, k minus alpha? Because this will be at the distance of alpha with if I keep as k, and this will be at the distance of alpha, hence this will be k plus alpha and this will be k minus alpha. Okay, so a will be h plus beta comma k plus alpha, and b will be h minus beta comma k minus alpha. Okay, h minus beta comma k minus alpha. Okay, now what we are going to do is that we are going to use simple area under the curve basic thing, that is area bounded between the parabola and chord is 4 by 3. Now doing area with respect to x-axis is difficult, so we'll do with respect to y-axis. Okay, so area is equal to 4 by 3 is equal to area of trapezium AB, let's say this is C, this is D, A, B, C, D, minus area of the parabola which is lying under the y-axis. Okay, basically this region. Basically this is our required area. Okay, and the pencil shaded is the area that we have to subtract from the area of trapezium. Okay, and area of trapezium ABCD is simply nothing but the average of parallel sides into the height. Basically sum of parallel sides by 2 into height. Okay, now sum of parallel sides is DA plus CB, which is nothing but h plus beta, right? Because this is h plus beta, same h plus beta. Okay, and this will be h minus beta, and if you sum this you will get 2h, and divide by 2 you will get h. Okay, and into the perpendicular length which is 2 alpha, minus area of parabola. Now here the function is y square equal to x. Okay, it's not a function, so the equation is y square equal to x, and if I do with respect to y-axis, then I should be writing something like this, right? And next dy will be y square dy, and the limits will be from k minus alpha to k plus alpha. Okay, k minus alpha to k plus alpha, y square dy is equal to 4 by 3. Okay, now 4 by 3 is equal to 2h alpha minus, I'm going to write this directly and substitute the limits. Okay, because it's basic thing. So 1 by 3 k plus alpha whole cube minus k minus alpha whole cube. Okay, now if you see from this expansion you will get 4 terms. One is k power 3, then 3k square alpha, then 3k alpha square, then alpha cube. From here you will get k cube minus 3k square alpha, then 3k alpha square, and minus alpha cube. Now since there is a minus sign sitting over here, the like terms will cancel and the unlike terms will add up, and since the unlike terms are equal in magnitude, so we will get it twice of this term and this term, right? And these terms will cancel, this will cancel, this will cancel, this will cancel, so I will write it as 2h alpha minus 2 by 3 3k square alpha plus alpha cube, which is equal to 4 by 3. Now if I cancel 2 everywhere, then I will get 2 by 3 is equal to h alpha minus 3k square alpha plus alpha cube by 3. And if I take 3 as the LCM, then I will get to something like this. Okay, I hope you can see. Yes, so it will be 2 is equal to 3h alpha minus 3k square alpha minus alpha cube. Okay, if I take common of 3 alpha over here, then it will be 3 alpha times h minus k square minus alpha cube, which is equal to 2. So this is the equation we have got. Okay, so let us assume this is equation 1, and we need 2 more equations, and we can get 2 more equations by the fact that these 2 points satisfy this function and this equation. So h plus beta would be k plus alpha whole square. If I expand, it is simply k square plus 2k alpha plus alpha square, and similarly the h minus beta as well. H minus beta is equal to k minus alpha square is equal to k square minus 2k alpha plus alpha square. Since beta is not appearing, so it is clear that we have to cancel, and simply by adding can cancel it. So 2h is equal to 2k square plus 2 alpha square divided by 2. H is equal to k square plus alpha square. Now if you look at equation 1, h minus k square is something which is unknown for us, even alpha also. So if you write h minus k square is equal to alpha square and substitute this in equation 1, then we will get something like this. Okay, this is the equation 1. I am writing it over here. 2 is equal to 3 alpha h minus k square minus alpha cube, and if I substitute this over here, then it is simply 3 alpha cube minus alpha cube, and that is equal to 2. Okay, and 2 alpha cube is equal to, which implies alpha cube is equal to 1, which implies alpha is equal to 1. Okay, I don't tell here plus minus 1 because cubic functions are 1 function, as you can see here. So for 1 you will get 1 only, so alpha is equal to 1, and if alpha is equal to 1, if I substitute alpha equal to 1 over here, you will get h minus k square is equal to 1, or nothing but k square is equal to h minus 1. If I replace k with y and h with x, you will finally get y square is equal to x minus 1. Okay, so this is the locus of S. Okay, now if you see, I have not used anything related to conic section, like applying t equal to s1 or applying area shortcut or parametric approach. I didn't use any of those things. I simply used basic 9th standard concept, which is the expansion, 10th standard concept, which is this one, right, and simple 12th standard concept, which is this one, right. So I hope you enjoy this approach, you like this approach. If you like this approach, then please consider dropping your feedback in the comment section. I will go through your feedbacks, but I will not be able to respond them because I am a student. I have my own exam preparation. So that's it for this video. We'll see you soon. Until then, take care. Bye bye.